All right, so this is the last part of Pythagorean theorem. So what we saw last time, right? Right? We see that the numbers that we are dealing with, right, are just solid numbers, right? We have 12, we have 13, we're trying to find b, right? We have 4, we have 5, we're trying to find b, right? And then we look at these examples where we still have whole numbers, but we notice that we are starting with a radical. Okay, so this goes back to the very first day, right? We went ahead and we talked about what it means when we have a radical tree times a radical tree. It just gives us tree, right? Same thing if I took radical 6 and I squared it, right? If we have a radical and we take the square root of a radical, right? In other words, if we have a square root and we square that square root, what happens is that whatever number is right in it comes out, right? So the square undoes the square root, okay? So let's go ahead and take a look. So, right, same exact thing. I can go ahead and actually do this math. So radical 10 squared just means that we have radical 10 times radical 10, right? I'm going to multiply the numbers inside my radical. So radical 10, or 10 times 10, gives you 100, right? And then I'm going to go and pull out my calculator. Oops. Guys, with this new update, it's crazy. Okay. Let me get out of this. Oh my gosh. Right, 10 times 10 is 100. I take the square root of 100. That just gives me my 10, right? So whatever is inside your radical goes ahead and just pops right out, right? Same thing if we were to do with this example right here, okay? But let's just go ahead and start. So it says find the missing side of each triangle, leave your answer as a radical, and then round the nearest tenths place. So whenever we're doing Pythagorean theorem, we're going to go ahead and round as much as possible. Okay, so we're rounding to the nearest tenths place, and remember the tenths place just means that we are one place after the decimal. Okay, so number 1, here we go, right? We can go ahead and label the triangle. Going back to earlier, right, here is side B, so across from side B is angle B. Angle C is always going to be wherever the right angle is, right? And then we have angle A, right? So here's C and here's A. And let's go and set up the Pythagorean theorem, right? I know Pythagorean theorem is A squared plus B squared is equal to C squared. And then I just go and plug and chug, right? It looks like A is radical 5. Make sure that you're pairing it up. A is radical 5. So I have radical 5, I'm going to put it in parentheses, squared, right? Plus, I don't know what B is, so B squared remains the same. And then I'm looking at C, right? C is radical 14. So this becomes, I'm going to put in parentheses, radical 14, close my parentheses, and I'm going to square it, right? If you don't believe, you can go ahead and actually plug in your calculator. But I have radical 5 squared gives me 5, right? So then I could just keep going. Radical 5 squared gives me 5 plus the b squared remains the same. That's what we're trying to find, is equal to radical 14 squared, which is just 14. Again, if you don't believe, plug it in, right? And then from here, we are just solving for b. So I'm going to go ahead and put my line. I'm going to subtract 5 on both sides. I'm left with b squared is equal to 14 minus 9. Ooh, 14 minus 5, I gave you the answer, which equals to 9. And then same thing that we kind of talked about earlier, right? B squared just means b times b, right? I need only one of the b's. That's what we are trying to find, right? So to undo that square, I have to take the square root of both sides. So then really all you're plugging in is square root of 9, which gives you a b is equal to 3. And that's your answer. This one we did not have to round. Okay, let's go and try example 2. right? Same exact thing. Uh-oh, I noticed that my original numbers have radicals. Right, before we go and start, let's go and label the triangle. So I have side B across from side B is angle B. Right, angle C always has your right angle at angle A. So then radical 10 is side A, radical 14 is side C. Right, same thing, A squared plus B squared is equal to C squared. Right, A squared, that gives me the radical 10 squared, plus B squared, that's what we don't know yet, so I'm going to keep it the same, is equal to, in parentheses, C squared, which is radical 14 squared. Right, you guys are going to get into practice where you don't have to do the math, right? I know that if I have a radical 10 squared, the radical and the square, they undo each other, so they cancel out. So what pops out is just 10 plus the B squared is equal to 14, radical 14 squared, which is just 14. And then I can go ahead, this looks a lot prettier. I can go and solve. Subtract 10 on both sides, and with B squared is equal to 4. Right, same exact thing. I have to undo the squaring, right? So I'm going to take the square root of both sides. I get B is equal to radical 4, which gives me a value of 2. Okay. I want you to try example 3. Press pause and try it, at least setting up the problem. All right, let's go and do problem number 3. So same exact thing, I'm gonna go ahead, and this time I didn't prompt you guys. I want you guys to go and set up your equation just like how we did, right? But let's go and first start by labeling the triangle. So here is side C across from side C, and always where the right angle is, that's angle C. And A and B don't really matter, so I'm just gonna put angle A there and angle B there. So that means across from angle A is little a, across from angle B is little b, and we have enough information to go ahead and provide our Pythagorean theorem, right? I have a squared plus b squared is equal to c squared. I know this part gets super repetitive, but I want us to go ahead and write it every single time. Okay, so a squared, right? A is radical 11, so I'm going to start with radical 11 squared plus b, which is radical 46 squared, is equal to c. We don't know what that guy is, so I'm going to leave it as c squared. Same thing, right? I'm in the practice. If I have radical 11 and I square it, it just becomes 11. Right? If you don't believe, you're like, Miss Welter, this is crazy math. There you go. Radical 46 squared is just 46. Is equal to c squared. All right, again, we're just solving. So I'm going to go ahead, 11 plus 46 gives me 57 is equal to c squared. Again, I'm trying to find one of the c's. So I'm going to go ahead and undo the square, and I'm going to take the square root of both sides. The square root of 57, you get a c value. This time around, we have a decimal, so we are going to go and round, right? I'm going to go and just write out 7.549. The directions told us to round to the nearest tenths place, so one place after the decimal, right? So I'm going to look, right? I'm trying to figure out, okay, are we rounding the 4 or are we keeping it the same? Or sorry, are we rounding the 5 or are we keeping it the same? To know that, all we have to do is go and look at the next number over, which is 4, right? Remember the rounding rules? If it's less than 5, we keep it the same. If it's 5 or more, we go ahead and round the number up, right? In this case, the number is 4. It is less than 5, so your answer should just be 7.5. Okay. All right, last one. Here we go. Same exact thing. Let's go and start by just labeling the triangle. I have always by the right angle is my angle C. And then in this case, A and B don't really matter, right? So then side A is my radical 17. Side B is my 5. All right, here we go. Same exact thing. Let's go and write up the setup. I have a squared plus b squared is equal to c squared. Right? A, in this case, is radical 17. So here's my radical 17, and I'm going to square it. Plus the b. Whew, guys. The b is different from the a. We notice that a is radical 17. Side b is just 5. So I'm going to keep it as 5 squared. We're trying to find the hypotenuse of c squared. Okay. This one I'm actually going to go and plug it into my calculator. Right? If you don't believe me, if I take a radical 17 and I square it, it just gives me 17. In this case, right, 5 squared is not 5, right? It does not have a radical. So there's nothing to undo. There's nothing to cancel out. So 5 squared is equal to 25, is equal to c squared. There is a difference between these two values, right? 5 squared, 5 times 5 is equal to 25. Radical 17 squared, that goes back to this guy, radical 17 squared, right? If we were to go ahead and look at it, that means I have radical 17 times radical 17 is equal to, I don't even know what 17 times 17 is equal to radical 289. Take the radical of 289, that gives you 17, right? These values are different, so make sure that when you guys are working through it, you are applying what you know about when I take a radical and I square it, and whenever I take a whole number and I square it, right? So that's why there's a difference in those values. Okay, so let's keep going. 17 plus 25, that gives you a value of 42. And same exact process, right? You're always gonna have c squared, a squared, b squared, x squared, right, is equal to some number. You have to find one of the values. So I'm just trying to find little c. In this case, I'm gonna take the square root of 42. Yee, we do get a long decimal. I'm gonna go and say 6.480, right? We're rounding to the nearest tenth. So I'm trying to see if I have to round up 4 or I keep it the same, right? How I know is I look at the next number over. The next number over is more than 5, so that means I do round up the 4. So this becomes 6.5, and that's your answer. Okay, so that's it, guys, with the Pythagorean theorem. Again, the most trickier ones is when we start with a radical versus just a whole number.